Hello everyone, welcome back to the Neo4j series. In this video, we will learn about indexes and constraints. We will also deep dive into how we can use the indexes in improving the query performance and also the significance of constraints in forcing the data integrity. We will also look into explain and profile concepts which is being used in Neo4j. So first of all, what we are going to do is we are going to create the base data, a small employee graph, which is we have used in our previous videos in this series. So let me first write down the queries. So we are creating a simple employee base data, which contains a data scientist, product owner, HR, and developer. Let me run this query. So yeah, so we have created the 4 nodes and 16 properties. We can see it on the left side. Now, then the next thing is we are going to add some relationship. It's just like the same how we have done it in our previous tutorials. So I'm going to add a relationship. Now let's add one more relationship. I'm going to get the query. So now we have added this relationship also. So we have added two relationships and we have 4 nodes in our base data. Now, what we are going to do, we are going to run some queries. Before diving into the indexes, we are going to run some simple queries and we can see what the Neo4j is doing internally. So let's say if we want to look up into our data with the help of a name by only one property. So let's say if we want to search for an employee whose name is Saurav. So what we have done, we have written, okay, this particular query. So where we are searching with the name property and the name of that particular employee should be Saurav. So let me run this one. So when we run this query, what happens here is that Neo4j scans all the nodes to find Saurav. So here we have 4 nodes. We have the data scientist, we have the developer, we have the HR, we have the product owner, but it searches for all of them where the name matches the Saurav things. Okay, so which is also called as node by label scan. And this type of searching process is very expensive when it comes to larger data sets. So since we are using a very small base data, so it's not going to be that much change. But if we use a very huge data set, so it can be really a problem. You can see it took 195 milliseconds and it completed in 212 milliseconds. Now, similar way, if we want to search with the multiple properties, so let me write down this query. Now let me run this one. Now, here we are searching with the help of the two properties. One is nationality and other one is the salary. So what happens here is Neo4j again scans all the employees, all the data scientists nodes, and then filter the results. So this is fine when we are using a smaller groups, but it is very terrible if we are dealing with a huge database. Like let's say if you connect your Neo4j database with a very huge data, and from there you are going to create the graph and all. So if that is very huge, so then it can become a really problem if you want to scale that particular thing. So so for to overcome this problem, we use indexing. So what happens with indexing is like indexing allows the Neo4j to directly jump to that particular matching node instead of searching for instead of going through all the nodes. So that's one of the biggest advantage of using indexes. So what we are going to do right now is like we are going to create indexes. Now indexes can be created on one single property. It can also be created on the multiple properties. So first we are going to look into how we can create the indexes using a single property. So let me write down the queries. So here we can see we are going to create the index on one property on name for the product owner and the name. So and then we have the name property or we have created for the different nodes for the data scientist, product owner, HR, and developer. Let me run this. So we can see all these nodes are being created. Similar way, we are going to create the indexes for multiple properties instead of only one property. So this type of index is called as composite index. So in simple words, a composite index is an index created on more than one property at the same time. Uh, so it is very much useful when a particular user is trying to run a query where he wants to filter a data using multiple properties. So it saves a lot of time. It takes a very less amount of time as compared to if you're not using index. So let me give an example of the composite index. So you can see I have created an index here on the two properties on nationality and on salary. And I have created the name of the index as employee nationality salary index. Let me run this. So we can see we have added one index. Now, if we want to see all the indexes which we have created, we can simply say show indexes and shift and enter. So you can is going to show all the indexes which we have created, okay, and its detail, okay, on which labels it is being created, what is the property, on which property we have created. So all these things are in detail, which we get into that show if we use the show indexes. So they are these indexes are very useful when when we try to do the queries on the multiple properties together or single properties. Okay, so let's take an example of the same query which we have used earlier. Now, if you again want to find out an employee whose name is Saurav, this is the same query which we have earlier used. Now, if I run this one, so you can see here it takes much lesser time, 150 milliseconds, as compared to much higher time which it took earlier. Similar way, if we try to search on the basis of multiple properties, let's say if we want to um, search on the basis of nationality and salary, we have already created an index. You can see here on the basis of nationality and salary. So if we try to search on if you try to search on this property, nationality and salary, it's going to give us the result in much quicker time. Okay, so so what's happening here is uh, Neo4j, with the help of indexing, Neo4j avoids scanning all the nodes. It directly goes to the place where it wants the particular result. So that's the advantage of using the indexes. The another thing is like let's say if we have two relationship here, right? Collaborates with and reports to. So what happens if we try to use the if you want to try to search based upon the relationship also. Let's say if I run this query. So here what we are trying to find it out, we are trying to find it out Saurav and uh, we are trying to find it out Saurav is the data scientist and the which manager he is reporting. So we have this relationship reports to manager. So when I run this particular query, so you can see here we get the name of that particular manager who is a product owner also. So what happens here is like we if we don't use the indexes, so what will happen is like the Neo4j will cannot find the starting node, cannot quickly find the starting node. Everything becomes very slow. Without index, it will look at every node. It will check the name. Okay, then it will search for Saurav, and then it will follow the relationship type. Okay, so it's like searching the entire city to find Saurav. Okay, and then asking who he reports to. But with the help of the index, what happens here is like with it instantly finds Saurav. Okay, and then follows the relationship like with whom he's saying. So it saves a lot of time. Okay, so that was about the indexes. So we can see that okay, with the help of the indexes, it saves a lot of time, and it's very much useful when it comes to the huge databases for making the queries more scalable. If we are creating any kind of a data pipelines for data scientists and we want to filter data monthly, and the data is getting huge, so in that case, indexes can be a very good choice of using it. But there is also one of the disadvantage of using index is that it doesn't prevent the entry of the bad data. So, and to avoid this particular problem, what we do, we have the constraints. The concept of constraints come into the picture. Now we are going to look into the constraints. So constraints are basically what happens here is like it enforces the data integrity. So it prevents uh, any kind of bad data entering into the database, like duplicates or wrong data type. It and one more thing is like when we are creating a constraint, it creates indexes too. So we can say that if somebody asks like what is the difference between index and constraint, we can say that index is more like kind of a Google search. You can search anything and it can give you also bad results. And constraints are more like kind of an bank actions where you have a lot of rules to get a particular data. So so this was a brief introduction about the constraints. So now we are going to create a constraint. So let me run a particular query. Now, when I try to create a constraint, so I'm getting a data exception. That constraint already exists. So we have already created an index. You can see here, if I go back, okay. So we are trying to create constraint on the data scientist. okay, on the name, but we already have a constraint on data scientist, okay, DS name index. So what we are going to do here is we are going to delete a delete this, because what happens is when we are trying to create a constant, it's also create the index in the background. But if the index is already created, it's going to give us this error that index is already present for that particular node. So what we are going to do, we are going to drop that particular index. So set, let me see. We have to create, we have to remove this one, ts index. We have to remove the double quotes, and we have to write drop index ds index. Okay, now we have removed this index. Now again we are going to create, we are going to create the constraints, the same query. Okay, now we will be able to create the constraint on this particular. So you can see here it has showing added one constraint. Now what we are trying to do, we have created a constraint on the ds name, on the data scientist. Now if I try to insert another, if you try to add a record, okay, a kind of a duplicate record here. So what will happen here is it is going to give me an error that it's already exist with that particular property name Saurabh. So we cannot have a multiple entry of employees with the same name. That's a kind of a constraint, okay, which we have created. So this is because we have already created a constraint on the name. So we can also create a constraint on multiple properties, like the employees cannot have the same name, employees cannot have the same designation, or two, three properties should not match of a particular employee. It should be unique, or it should not. The best thing is it should not have a unique ID. It should have a unique ID, not a duplicate ID. So that is the advantage of creating a constraint. So with the help of the constraint, you can't have a duplicate record. So it is going to give you an error that already exists, that record already exists, or you have to check into it like how we can add the data. So that's one thing. So basically what I intend to say is constraints block the invalid data before it enters the particular graph. Now, let's say if we want to create a kind of a one more constraint like this. So where we have put a constraint that the product owner should have a salary. It should not be a null value. So I have created this particular constraint. Now, now when I try to add a product owner, okay, let's say his name is Karan, and I have not provided the salary, so it's going to give me an error that it should have a salary, because we have already created a constraint that the PO should have a field called as salary also. And if I try to create a product owner only with the name without specifying the salary, then it's going to give me an error. So this is how the constraints helps us in maintaining the data integrity. Now, so this now again one more thing is like we can also create the property one relationship property constraints. So let's say if we want to create a relationship, so let's say if we want to create like something like this, repose to must have since, it should have also since here. Okay, since should not be a null. So let's say I have created this particular thing. So it is showing relationship type reports to must have the following property since. So okay, so when I'm trying to create this particular thing, it is giving me an error that it should have a since property because I've not mentioned that particular since. Okay, so this is the advantage of using the things. Okay, so now the next thing is we are going to create a uh, is now we are going to understand the other concept. So now we got right a little bit idea about constant and indexes. So indexes also helps us in query performance, but constant also helps us in query performance. But the thing is like it helps us also in checking the data integrity. Um, Now the next concept which we are going to look into is the concept of explain. So so in this case, what if Neo4j, what happens is like it executes query internally using explain. So explain with the help of explain, if you use the explain keyword in our queries, it shows how Neo4j plans to run a query without actually running it. So let's say if you are traveling to any place, and before a road trip, you look at the map, distance, and all the other metrics like how much time it is going to take. So Just similar like that, explain is also, it helps you that how it's going to, how Neo4j is going to execute that particular query. So let's say if we run this particular query. So this is a query which we have run. So it's going to explain us. So this is basically node by label scan. You can see here node by label scan. So it checks every node within this label, within this particular label. Okay, that we want a developer whose salary is greater than 90 this much. Okay, and we have to return the name and salary. So it's going to look into all the things. Okay, which is the developer. Okay, what's its name and salary, and that's how it shows us the result. Okay, this is about the node by label scan. So it basically it checks every node within this particular label. The other thing is node index seek. So node index seek is something which jumps directly to the index. So let's say if I run this and if I search for this one, so it's going to search for that particular unique name. Okay, unique data scientist where name is this much and this one. So it's going to give us the result. Okay, but in this case we don't have anyone whose name is Roy, so it's resulting nothing. It's not giving any result. Now, yes, so this is how we can this is about the node index seek. Now another thing is like we have the node unique index seek. So let me run this particular. So it finds out exactly the one node. So let me run this particular query. So you can see here node unique seek. So it's going to find out the exact one particular person who is there. Okay. So uniqueness, basically uniqueness allows Neo4j to stop after finding a single node. Now this was about the explain, and let me run one more query. So if we want to find it out the relationship like this, like if you want to return the name of the name and PO name, okay. So this is how we are going to get there. The name of the PO and data scientist. So it's going to give us the results. Okay, like this. With whom is collaborating, what is the name, okay, and then it results the name. Okay. So this is how it works. It's going to show us um, how the Neo4j is trying to search for the multiples. It's going to search for that particular result. Now, next thing is we are going to also look into the filter operation. So, so let's say if I want to search for the nationality and salary is greater than 80,000, where I want to return the name and salary. So it's going to do the filtering also based upon that, and it's going to give us the result. Okay. So this applies conditions after the data is being found. Now, the next thing is about profile. We talked about explain. Next thing is about profile. So profile, what it does is that it actually executes the query and show the real runtime cost, how much it will cost. So profile runs the query and shows the execution time. It shows the rows processed and how many databases it has had. So there also, so let me run a particular query. So this is the query, and it's going to give us, you can see here how much allocated memory, what is the total time. Okay, but in the previous case it was not showing the allocated memory and total time, but here it is showing the, let me go up, how much memory is being allocated and everything, and the cost and everything. It is going to give you the results. Okay, now next thing is it also has expand all in the case of profile. So it's going to give us what are the relationships. Okay, uh, it traverses the relationship after matching all of them. What are the relationships are there. Okay, then it also with the help of the profile we can also get the entire pipeline. Okay, like how does it check for this one. So I can show you. Okay, it is going to match for Saurav, product owner, where this is the salary, where we have the salary is this much and we have to provide the name and the PO name and the PO salary. Okay, so we can see it searches for this one and then it produces the results. Okay, and then it also gives us how much is the time. what is the total database access, and what is the total memory, how many databases being hit. So this was all about in this video. If you have any questions, and uh, and if you want to discuss any topics related to this, so please put your doubts in the comment section, and please like, subscribe, and follow for more videos. Thank you.